Hi, Woodstock students. This is Mr. Brennan, and I'm here to share with you some solutions on our recent AP Physics exam free response questions. I'm going to go through question one here, and I think I'll try to do one video solution for each of the 5 questions. The very first question was a spacecraft in orbit around the Earth, a 7-point question with a suggested time of 13 minutes. And it just reads: a spacecraft of mass m is in a clockwise circular orbit of radius r around Earth, as shown in the figure above. The mass of the Earth is m sub e. And then the first question is to draw and label the forces that act on the spacecraft. So each force must be represented by a distinct arrow starting on and pointing away from the spacecraft. I was surprised at how few students successfully addressed this question. The essentially only force acting on the spacecraft is this gravitational force of the Earth on the spacecraft pointing towards the center of the Earth. It is, in fact, a centripetal force, but they weren't asking you to interpret the force or to calculate it, but to simply label it. And so it was a 1-point question, one of the 7 points here, and you just needed to identify the gravitational force of the Earth on the satellite. Some common errors: people sometimes drew in an arrow that was tangent to the orbit, calling it velocity, which that's certainly true. There is a velocity, but that's not a force. Some people labeled it momentum, which is also not incorrect, but it's not a force. Some folks had some arrows pointing outward. Not sure what that was about. Anyway, so you may have gotten half a point if I noticed you got in FG there when you added in some other things. But I was surprised at how few people got the full point on that. Let's take a look at the next part here. You were asked to derive an equation for the orbital period t of the spacecraft in terms of m, the mass of the spacecraft, the mass of the Earth, r, the distance between, or the radius of the orbit, and physical constants like big G or the speed of light or anything that might come up. So it says to show this in the space below, but I went ahead and added some space on the next page. So let's take a look at that second page, and I'll try to draw your attention to just the part that I want us to be looking at right here. Okay? So the key to this is to recognize that on the right-hand side, Newton's law of gravity, big G times m times me over r squared, is equal to a centripetal force. It's the only force acting on the object, as we said before. It's pointed radially inward, and so it's a net radially inward force, or a centripetal force. We've got a formula for that, mv squared over r, and that's equal to big G times m times me over r squared. The mass of the satellite cancels out, so that goes away, and I multiply both sides by r to get to G times me over r. So far so good, but the question asks for solving for the period. So here's the second recognition you need to make. So first recognition is that the centripetal force can be set equal to the gravitational force, and you can get to this place here. The second recognition is that the velocity does involve the period, right? The time around the circle is the circumference of that circle. So 2 pi r over t would be the velocity. 2 pi r is the distance, t would be the time. Everything gets squared, so I've got 2 pi r squared over t squared, and that's equal to g times m sub e over r. And then finally, if we square everything and get t by itself, I can multiply both sides by t, multiply through by r and square all those things. Eventually get to a place where you're going to have t squared is equal to 4 pi squared r cubed over g times me. Now I could put a radical sign around that whole thing and just get t, but I chose to stop right there. It was a trivial last step to take. Okay, so you can see what happens here. You can predict how t depends upon the radius or the mass of the Earth and physical constants like 4 and pi squared and g. Okay. So that was the solution there. If we go back to the question, the second part of the question says a second spacecraft of mass 2m is placed in that same orbit with the same radius. What will happen to the orbital period of the second spacecraft? Okay, and this says to explain your reasoning. Is it going to be greater than, less than, or equal to? Explain your reasoning. Well, if we take a look down here, we can immediately see that, let me just scroll down a little bit, that the mass of the ship is not involved in here at all. So the fact that it's at the same radius and is around the same planet means that it's going to have the same period. The period is equal to the previous period because the period does not depend upon the mass of the ship. So that was the end of part B of that question. All right, let's go back up to the top here and take a look at this now. Okay, is the speed of the spacecraft in the new orbit greater than, less than, or equal to the original speed? So again, going back to that. Oh wait, I'm sorry. There's a premise here. Let me just consult the. My photograph doesn't show the right premise. Hang on one second. Let me just get my settled. Okay, so my photograph is just off a little bit, but just above the photo here it says the first spacecraft is moved into a new circular orbit that has a radius greater than r, shown in the figure below. So you can see this was the original orbit here, and now it's out to this larger orbit. Okay, so the question is the speed, the velocity of the spacecraft in the new orbit greater than, less than, or equal to the original speed? So over here on the right, if I go back to what I had over here, v squared equals g times me over r, then we can pretty quickly come to the conclusion that as r increases, v squared must decrease, and therefore v must decrease. Okay, so that was worth 2 points, and all we did was steal this logic from over here, steal this little algebraic statement from over here to recognize how the velocity depends upon radius. Okay, so that's question number 1. I'll post this and get a second video going for question number 2.